Welcome, students, for the lab number 7 DBMS course. Today's topic is indexing. So, our objective for today's lectures, after completing this lab, you will be able to display the indexes, create index explicitly, create unique index explicitly. Then after creating those indexes, we will see how to monitor the index usage and monitor the space use of indexes. So before we proceed, we need to understand or recall what are indexes. I hope you all have completed this topic in your theory class, but before we start our lab work, we will just have a little discussion on or recalling so we can align the activities today for the lab. So what are indexes? In a database management systems, an index is a data structure that improves the speed of a data retrieval operations on a database table at the cost of additional space and decrease the performance on write operations. Indexes are used to quickly locate the data without having to search every row in a database table. So indexes in DBMS work by providing a quick access path to the rows in a table based on the values of one or more columns. So when you create an index on a column or a set of columns in a table, the database system creates a separate data structure that stores the values of those columns along with pointers to the corresponding rows in the table. So you see that the indexes have their own pros and cons. So as a database administrator, it's you who decide that in what situations we should go for the indexes and what situations we should avoid the indexes, because it creates, no doubt, indexes are helpful in improvement of the database operation speeds, but at the cost of the extra storage. So these are some key points about indexes in the DBMS. Number one, as I told you, that improved query performance. So indexes help improve the performance of the select queries by allowing the database system to quickly locate the rows that match the conditions specified in the queries where clause. Another important point is the faster sorting and grouping. Indexes can also speed up sorting and grouping the operations as they provide an ordered access path to the data. We have unique constraints. In many cases, indexes enforce the unique constraints on columns, ensuring that no two rows in the table have the same value in the indexed column. So next is the primary and foreign keys. In relational databases, the primary keys and the foreign keys are often implemented using indexes. Primary key constraint create a unique index on the primary key column to ensure the data integrity, while foreign key constraints typically create indexes on the columns referenced by the foreign keys. Also, indexes are useful in maintenance overhead. While indexes improve query performance, they also come with a maintenance overhead. So as data in the table is inserted, updated, or deleted, the corresponding indexes must be updated to reflect these changes, which can impact the performance of the write operation. So as I tell you, the indexes are very good in improving the speed of database operations, but at the cost of the extra storage. So they have the maintenance overhead. Number 6 is index types. Different types of indexes are available in DBMS. We will see, or in Oracle also provide the default indexes. So including single column indexes, composite indexes, like indexes on multiple columns, unique indexes, and clustered indexes where the physical order of the rows in the table matches the order of the index. So index selection means that choosing the appropriate columns to index is crucial for optimizing the query performance. So indexes should be created based on the columns frequently used in where clauses. join conditions, and order by clauses. So overall, the indexes play a vital role in optimizing the performance of database queries and the operations, but they must be carefully designed and maintained to achieve the desired performance benefits. So let's proceed further towards the exercises. So as you know that we are using the HR schema, the built-in HR schema in Oracle database. So this is how we, first of all, as we discussed already for our previous sessions, that we need to first connect with the HR schema. So you can open your SQL Plus and connect using HR account. So these are the steps which we already discussed and did many times. Just here I put it for the reference. Okay, so as you see that we have how many objectives? We have 5 objectives for our today's lab. Like first, we will see how to display indexes, the built-in indexes in the HR schema. Then we will create the explicit indexes and the unique indexes, and then we will see the monitor index usage. So the first objective of our today's lab is to display indexes. So how we display the indexes? Now, this is the command we are using. Select, as you know, display indexes, we are using the select command followed by the name of the index, right? So, and these, let's break up this, query. So this query retrieves the information about indexes owned by the current user in the database. So if we break it, so we start with the select, which is a reserved word, and this keyword is used to retrieve data from the databases. Then we have the index name and the table name. Separate index name separated by comma, and then we have a table name. So after select statement, girls, you know that we have to provide the list of attributes. So these are the columns we want to retrieve from the user indexes view. So from user indexes is what? It's a view in Oracle database. So we are interested in the names of the indexes, only the name and the names of the tables to which these indexes belongs. So from user indexes is what? This part specifies the source of the data, which is the user indexes view in Oracle database. The user indexes view contains the information about the indexes owned by the current user. So when you execute this query, it will return a result set which contains 2 columns. You can see the 2 columns, the index name and the table name. And each row in the result set represents an index owned by the current user, along with the corresponding table name to which the index belongs. Now you can see the index name is, let's say, IXS1, and the table name, it's XS dollar. Similarly, another index is available is ACL MBW, and it belongs to the ACM dollar. So this is the query which return the result set which contains the the columns or the attributes we specified after the select command, select reserved word. Okay. Now this is the second statement. Now you can see over here. For the unique, not for the unique, so this is another command, right? Now, this command, if you see here, it again starts with the select keyword, and it retrieves actually what? Select index name from user indexes where table name employees. Now, here actually we are making our search specific and want to see the indexes only for the employees table. So since yet we did not create any index, so here you can see the no rows, the result is no rows selected. Now let's discuss this command. As you see, after the select statement, what we did, we have to provide the name of the columns. for which we want to retrieve data from the database. So we want the index name, right? Index name, and the name of the index is index underscore name. So this is the column. Actually, we want to retrieve from the user indexes view, and we are interested in the names of the indexes associated with the specified table. So in our case, the specified table is the employees. You can see here. Okay, so from here, from user indexes, again, this specifies the source of the data, which is the user indexes view. And in Oracle database, as I tell you, the user indexes view contains the information about indexes owned by the current user. Okay, now, since we want to make our search specific for the employees only, so when we want to make our search specific, we use the where clause. So after the where clause, like you see here, we have to give the name of the table name, which is the employees. So this condition actually filters the results to only include the indexes which are associated with the employees table. So the table name column is compared to the string employees so that to match the desired table. So when you execute this query, it will return a result set containing the names of the indexes that are associated with the employees table in the database. But here you see when I execute this query, there is no row selected option is there. So as I tell you that it is because we had not created any indexes. So we will create and then we will see. Okay, now the second objective is to create an index explicitly. So creating the index explicitly means that this statement which you see here, it actually creates the index name idx first underscore name, right? Column on what? On the employees table, and this create is the DDL command. So create the full statement, create index idx first underscore name on employee's first name. Now, till then, this actually part of the statement and specifies that an index, what the name of the this create index is actually the reserved word, and then this idx first name is the name of the index, right? So will be created on what? On the first name of column of the employees table. So an index on this column will help optimize the queries that involve searching or sorting by the first name of the employees. After that, you see the another part of that query, which starts from table space users. Now table spaces we discussed in our previous lab also in the storage. So this actually command specifies the table space in which the index will be stored. So in this case, in our case, it is the users table space where our newly created index will be stored. Okay, now the last part for our query. Storage, initial 20K, next 20K, PCT increase 75. Now this section of our part of our query sets the storage parameters for the index. So what are these parameters? Initial 20K. This initial 20K means the initial size of the index segment in kilobytes, and in our case, it is set to 2 kilobytes. Now, next 20K means the size to increase the index segment by when additional space is required. So here we set it to more 20K, right? It 20 kilobytes. Final is the last part is the PCT increase 75. Now PCT I'll talk later also, but at the moment you understand it specifies the percentage by which the size of the index segment should increase when more space is needed. So in here we set it to 75%, meaning that when additional space is required, the size of the index segment will increase by 75% of its current size. So overall, this SQL statement creates an index on the first name column of the employees table with the specific storage parameters within the user's table space. So you see when we execute this query, the result is the index is created. Okay, now creating a unique index explicitly. How we can create the unique index explicitly. So so since we are going to create another index, so we'll start with the DDL command specific word create, right? So overall, this complete SQL statement creates a unique index with the name of department underscore unique underscore index on the departments, and the column name is the on the departments table on the column name department's name. So again, we break it, create unique index, right? Create unique index is what? These are the reserved words. Before we use just create index. Now we want to create a unique index. So unique is also a part of this key. It's a reserved word and the part of this statement, followed by the name of the index, which is we give department underscore university uni underscore index, right? So this part of the index statement specifies that a unique index will be created, right? And this is the name of the indexes we specify after create unique index. Okay, now on departments and in the parenthesis we have department name. So this part specifies that the index will be created on the department underscore name column of the department's table, and a unique index, since we are creating a unique index, so it makes sure that each value in the indexed column must be unique, meaning there should not be any duplicate values for department name in the department's table. Last is the table space users. I just discussed in the previous example, the table space users specifies the table space in which the index will be stored. So here we have the table space, we are using the users table space. Previously, we provide the parameters, the storage parameters. So this can also be, we can do it this way as well, right? So overall, this SQL statement creates a unique index on the department name column of the department's table, ensuring that each department name is unique within the table and it will be stored in the user's table space. Okay, now we are done with the creation of both type of indexes. We see how to display the index, we see how to create the index, we specifically see how to create the unique index. Now the next objective of our today's lab is to monitor the index usage. So monitoring the index users, we are using this command, alter index employee underscore email underscore UK monitoring usage. So overall, this statement, as we see using the alter command, this is also a DDL command. So this SQL statement alters the monitoring usage of an index. The name of the index is employee underscore email underscore UK. So this part, if we understand this SQL statement, So we break it in that. So you can see the alter index. They both are what they are, the reserved keywords, right? If you want to make the changes over here, then you must have to first alter index and command followed by the name of the index with that you want to alter. Then we have the reserved word monitoring usage. So monitoring usage, this clause of our statement indicates that you want to modify the monitoring usage of the index. So monitoring usage actually allows you to gather the statistics about the usage of the index, such as how frequently it is accessed or used by the queries. Now, after that, you can, after turn on the monitoring usage, now the second is you need to view the index usage. So for that, you have to, use the command select star from v dollar object usage. So first we understand what is the, what's this query and what the query will retrieve. So this query retrieves actually the information from the dynamic performance view v dollar object underscore usage. And it contains the data about the usage of database objects. So select star, we know that this part of the query instructs the database to select all columns from the specified table or a view from v dollar object underscore usage. Now this part of our query specifies the source of the data, which is the dynamic performance view named v dollar object underscore usage in our case. And this dynamic performance view in Oracle provides the real-time information about various aspects of the database's performance and the configuration. So when you execute this query, you will retrieve a result set containing the information about the usage of database objects such as tables, indexes, or clusters. So this information can include the details like the object name, type, and the number of times the object has been accessed or modified. You can see the result of this query. So select star from v dollar object usage. It shows us the index name, table name, monitoring usage. You see, we just turn on the monitoring usage for this index, right? EMP, EML. So the monitoring usage is turned on. So yes, and the usage is no. The start monitoring date, time, and the other information is shown over here. So this is actually this command. I want you to check the schema or the definition of the v dollar object, right? So by using this command, so you can see we have index name, table name, monitoring, and usage, and the start monitoring, end monitoring, which we see here in this result. So this is the same thing. Let's move on to, okay, another important concept here is to turn off monitoring usage, right? Girls, as we, it's very important to, when we start our, start monitoring usage, so it occupies actually it uses the resources, right? So when you are done or you don't need, you need to, it's a good practice and a highly recommended practice to turn off the monitoring usage. So how to turn off the monitoring usage? We are using the same command which we discussed before. Just here, we, instead of monitoring usage, we are showing here no monitoring usage, right? So alter index employee underscore name underscore ix. Alter index is the result keyword, and this part of the statement specifies the index that we want to alter. with a name. Then no monitoring usage. So this clause indicates that you want to disable this monitoring usage for this specific index. So monitoring usage, as we discussed already, that it allows you to gather the statistics about the usage of the index, right? So if you don't need it, it is good to turn off your monitoring usage, because unnecessarily it uses your resources. Okay, the next is the monitoring space use of indexes, right? Monitoring space use of indexes. Here you can see this SQL query is select for the percentage of space used, like PCT underscore used for an index with the name index from the index stats table. So select PCT used part is actually specifies that you want to retrieve the percentage of space used from the table. From which table? From index stats, right? So the source of the data, which is index underscore stats table, and this table actually typically contains the statistics about the indexes in the databases, including the space utilization. Then we need to, since we are actually interested in some specific data, so we need to filter it out by using the where clause, where name is the equals to and the name of followed by the name of the index. So this condition filters the results to only includes the rows where the index name is IDX underscore first underscore name, right? So this allows us to retrieve the statistics specifically for this index with the name which we mentioned over here. But here you see again no rows are selected, so it is the case because there are no maybe it's not accessible. Okay, now let's further talk about the PCT percentage of the space used. So the percentage of index space usage varies according to how often the index keys are inserted, updated, or deleted. We have these four, uh, we can perform it in the four ways, like analyzing statistics, validating the index, checking PCT underscore use, dropping and rebuilding, or the indexes. So it actually develops a history of average efficiency of the space usage for an index by performing these sequences of operations, right? Here, this slide shows us some views and their descriptions, like DBA underscore indexes, all indexes, user underscore indexes. These views are actually used by the DBAs to view the describes the indexes on all tables in the database. So all view describes indexes on all table accessible to the user. User view is restricted to indexes owned by the user. Some columns in these views contain statistics that are generated by the DBMS underscore stats package or analyze statement. Now you can see here, we use this $object underscore usage command. We just use it which contains the index usage information produced by the alter index or monitoring usage functionality. Similarly, we have more views are available. Like you see DBA underscore IND underscore columns and all underscore IND underscore columns and user underscore and underscore columns. So these views actually describes the columns of the indexes on tables. Some columns in these views contain statistics that are generated by the DBMS underscore stats package or analyze the statements. So similarly, we see if you want to see this index statistics, so you can use the view is index underscore stats. We just use it. So which stores information from the last analyzed index, validate structure, statement, so on and so forth. So these are the some, for your understanding, some views and their descriptions in the database are available. Okay, now the lab tasks. For the lab task, first, before we have 4 activities. So before you start any activity, you first need to, before you proceeding, you need to turn on the monitoring usage of some indexes. These are the commands we just discussed, that how we can, turn on the monitoring usage. So you need to, turn on the monitoring usage on three indexes, right? Order index, employee underscore email underscore UK, employee underscore ID underscore PK, primary key index, and the employee underscore name underscore IX. These three indexes you monitoring usage you need to turn on before you start your activities. So as you know that, as I tell you, in Oracle databases, you can enable the monitoring of index uses by setting just the monitoring usage attribute on an index. So this allows you to gather the information about how often an index is being used. So let's proceed to our first activity. So this is our first activity in which you need to create an index with the name of employee underscore hire underscore IX using the hire date field of employees table, right? And later, you need to run a SQL statement that display the hire date field of all records in the employees table. Then finally, you need to drop it at the end. So we just discussed, we just see that how to create the indexes. So you need to use the create command. So create index command followed by the name of the index, which is given in our activity. And where on employees table, the column name is hire date. Then after creating it, now you need to select the hire date from the employees, and finally you need to see that if we don't need the indexes, I tell you that indexes are very good for the improving the database speed and operations, but at the cost of the extra storage. So if you don't need any index anymore, the good thing is that to drop that in index, right? So this is the command you can use for dropping the index. Activity number 2, it says that run a SQL statement that will display all the fields from the employees table for employee ID 1-to-1 for the specific employee whose ID is 1-to-1, then view the $V object usage afterwards, and then notice what you notice out of it. So this query, this activity has two parts, right? So the first part is to create, to select the employee ID, the employee whose ID is 1-to-1, the information about that employee. So we write here select star. Star means we are not interested in specific columns or attributes. We want all the attributes to be selected. So select star from employees where, but we want to make the selection on the number of rows. We don't want the data for all the employees. We are interested only for the specific employee whose ID is 121. So it will give us the all data related to this specific employee. Like you can see employee ID, first name, last name. So employee ID is 121, first name is Adam, and the last name is Fripp. The email of this person and the phone number of the person and the hire date, salary, and this is the salary and the commission VCT and the manager ID, manager of this specific person and to which department it belongs, the ID of the department. Okay, after this, the second part of our activity number 2 tells us that we need to view the $V object, right? So $V object, we just discussed that actually it tells us how to the monitoring usage of our of our index, right? So select star from $V object underscore usage. We write this query and it shows us the index name, the table name, monitoring usage, and the use, because we did not turn on the monitoring usage of this. It maybe this information is different from yours on your system as from mine, but because it depends at what time you're creating your indexes. So this is shows all the information and the statistics related to the index. We write it. Now the next activity, which is activity number 3. Now activity number 3 says we need to run a SQL statement that will display the email feed from employees table, and then we'll see the view v dollar object usage afterwards, and then we'll see the notice the here there in we need to notice that what is the difference. So first of all, we see the write the statement to select the email from the employees, and then we write the statement select star from v dollar object usage, and then you see the notice what the differences are there. The last activity is about to run a SQL statement that will display the first name, last name fields from employees table plus job underscore ID and department underscore ID fields from job underscore history table. So, and finally, you also again have to go for the v dollar view the v dollar object underscore usage afterwards and see the differences. So these are the results you can see here about the queries, right? First you run this query and select the appropriate given attributes like first name, last name from employees table, and then we need the job ID and the department ID from the job history table, and then we will use the usage of of you by running the command v dollar object underscore usage, right? So it says the same thing. It shows the index name, the table name, the usages, the start date. Monitoring is yes, monitoring is for this index, the monitoring is turned on. For this index, the monitoring is turned off, and the different information about the start monitoring and the end monitoring. Finally, we are, as we tell you, that's highly recommended that after turning on the monitoring usage, when you do not need it, you need to close it. So before closing your SQL command line, you need to turn off the monitoring usage by using the commands no monitoring. Just you have to change at this point. So this is all about our today's lab, and please try it yourself, complete it, and submit your work on time through Blackboard.